Hey guys! So today is a major lesson in the world of pre-calculus, algebra 2, math in general. So today we're really finalizing and putting together the unit circle. A few things I asked you to look over recently or that we just learned were the 30, 60, 90 and 45, 45, 90 special right triangles from geometry. We also went over right triangle trigonometry, or SOHCAHTOA, as some of you may refer to it as. And we've been working on a unit which is exclusively periodic functions and trigonometry, where we discussed periodic functions, analyzed periodic data, we drew angles in standard position. We also did degrees, minutes, seconds, and radians. So we're going to start off by really solidifying our understanding of 30, 60, 90 triangles. So whenever we work with a triangle problem, you probably want to sketch it out. 30 degrees is in my lower left corner, and 60 degrees is in my top right corner. Now, the expressions you use to label each side back in your days of geometry included the value of x across from 30 degrees. X radical 3 was the longer leg, which is across from 60, and 2x is across from the 90 degree, or it was the hypotenuse. So the hypotenuse was twice the length of the short leg. Next, we are going to draw our 45, 45, 90 triangle. The angles are really telling you that you're working with a right isosceles triangle. The measures for each side is also from geometry, from your days of geometry. You should know, and if you didn't know, you should have looked it up and kind of refamiliarized yourself with it. We will use x again, but it doesn't mean it's the same x as the triangle on the left, okay? X is going to be the length of a leg, which is really telling us it's the length of both legs because, like we said, this is an isosceles triangle. And then the hypotenuse is x square root 2. The square root of 2 is bigger than 1, so whenever we multiply a number by something larger than 1, it gets bigger, so it does make sense that the hypotenuse is x square root 2. Another thing that we should just go over for vocabulary purposes is just make sure you know that the 30 and 60 degree angles and the 245 degree angles are what we call complementary to one another. And we're going to do an example now where we will use those expressions that you should have in your notes to solve triangles. And when you solve a triangle, it just means you're finding all of the missing sides and all of the missing angles. 3 sides, 3 angles. Obviously, you're going to be given some of this information, but you do what you got to do to get the missing parts. So we have a right triangle, and I'm going to label my vertices A, B, and C, and then the sides opposite each angle will be the matching lowercase letters. So across from angle B, you saw lowercase b, across from angle C, we have lowercase c, and so on. So if I give you this 30, 60, 90 triangle, and I only tell you that C is equal to 1, I want to know what are all of my angles, capital A, capital B, and capital C, and what are all of my side measures or side lengths, lowercase a, b, and c. I was given 30 degrees, and really you're given 90 degrees because it's a right triangle, and we were given the measure of 1 for the hypotenuse. Now, what's the first thing we should probably find? Well, I'm going to go ahead and say let's find the missing angle. It's probably the easiest thing to find. You just add 90 and 30 and subtract from 180, or better, way better, is to just subtract 30 from 90, because if 90 degrees is taken, then you only have 90 degrees left for those two angles to share. Remember, we said they're complementary angles. Now we're going to find our side lengths, and I'm given the hypotenuse. The expression we just saw for the hypotenuse was 2x, and that side length I am told is 1. If 2x is 1/2, then the x value, solving for x, is 1/2, and you get that by dividing both sides by 2. Since x is the expression we use to represent the side across from the 30-degree angle, that means that side A is equal to 1/2. The longer leg, or leg B, is equal to x radical 3. And since we know that x is equal to 1/2, then x radical 3 must be 1/2 times square root 3. And a better way to write it is b equals radical 3 over 2. So we have just solved our first example, and this triangle is actually going to matter quite a bit moving forward. All right, it's really important that you know this case really, really well. Okay, 30, 60, 90 triangle where you have 1 as the hypotenuse. What is the decimal value of these? Well, before we even do decimals, 1/2 is the same as square root 1 over 2. I know that's weird, but that tells me, well, square root of 1 over 2 is definitely less than square root of 3 over 2. So I know side B is shorter than I know side A is shorter than side B. Side B is approximately 0.86 something, okay? But I don't expect you to know radical 3 over 2 in your head, right? Like, who's going to know that? But what would be good to know is that radical 3 over 2 is definitely bigger than 1/2, or radical 1 over 2, okay? So that's also good to keep in mind. So let's remember that information as well. And that would just mean that if we were drawing this triangle and trying to make it to scale, you would just move over more than you move up. So you move over about 0.86-ish, and then you move up 0.5. That's all I want you to take away from that. All right, now example 2, and we are going to do another special right triangle, except of course now, well, this one's going to be the 45, 45, 90 triangle, and I'll still have a hypotenuse of 1, but this time I'm going to call my sides x, y, and z. 45 degrees in my lower left corner, and I'm going to call that angle theta. Then let's see, we'll call this top angle up here, let's call it 90 minus theta, because that's really a clean way to define it. Okay, so let's see what we got here. Let's solve our triangle, right? Let's find all of the missing sides and all of the missing angles. So I'm still going to make a list. Definitely list your angles and list your sides, and always put sides and angles that are opposite one another next to each other in the 2 columns. I hope that makes sense. If not, rewind and listen to what I just said again. So I have 45, 45, and 90. That was all really more or less given to me. Now, y is across from theta, x is across from 90 minus theta, and z is across from z. Z was given, and that's 1. X and y, okay, I'm redrawing my formulas that we just did for our warm-up, but it's coincidence that the x on the leg is also the x in the triangle formula. It doesn't always work out that way, so never make assumptions, okay? Really think about what you're given. Now, x square root 2 is the expression of the hypotenuse, which is z, and that's equal to 1. And should I cross this out? You know, I'm gonna cross it out because I was just gonna rewrite it, but whatever, it's fine. So x radical 2 must equal 1 if they're both equal to side z, right? That's basically the transitive property. Now, that's multiplication between the x and the square root 2. That's not addition, and that's not just them hanging out and being friends. To get rid of multiplication, we divide. 1 divided by square root 2, sure, it's a fraction, 1 over square root 2, but you've been learning since geometry to rationalize denominators. We don't leave radicals in our denominators. So we're going to multiply the denominator and numerator by square root of 2. Don't say you multiply by square root 2. That's not what you're doing. You're multiplying by square root 2 on the bottom, and you're multiplying by square root 2 on the top. Square root of 2 times square root of 2 is square root of 4, and the square root of 4 is 2. Beautiful. If that were a cube root instead, though, you'd actually do cube root of 2 times cube root of 2 times 2, because you would need 3 2's to get rid of the cube root. Just a little note. On top, we just have 1 times radical 2, so 1 times anything is itself. So radical 2 over 2. 1 over the square root of 2 equals radical 2 over 2. That is the rationalized value of the legs of this triangle. They're both the same because you go over to the right, the same amount you move up, right? That makes sense when you have an isosceles triangle. We have 2 congruent sides and 2 congruent angles. At least 2. Really, you could have 3. An equilateral will still be isosceles. Fun fact. Okay. Next up, we're going to do some work with the degree measures going around the unit circle. Okay, so let's see. I'm not going to draw the whole circle, and I'm going to kind of show you really by using tick marks in each quadrant. So 0 degrees starts on the positive x-axis, and 1 full revolution is 360. That is definitely where you should start for your degrees. Halfway between 0 degrees and 360 degrees is 180. What's between 0 and 180? 90. These are things that should become common knowledge to you over time. And if it's still something you need to divide in a calculator, you really need to just work on making those into memorized facts, okay? Or at least be a little bit more speedy with it. Now, what's halfway between 0 and 90 degrees? Halfway between 0 and 90 is 45. All we're going to do now is we're going to start at 0 degrees, and we're going to count by 45 to go all the way around this circle and make our way to the 360 degree mark. So 45 and 45 was 90, and another 45 is 135. If you think about it, when you add 45 degrees twice, you're really adding 90 degrees. 90 is the same as adding 100, take away 10. 45 plus 100 would be 145, take away 10, 135. Do the same to go from 135 to the next spot in the middle over here, and we'd get 225. I mean, 135 plus 100 is 235, take away 10, 225. Same idea with the 225 plus 100 is 325, take away 10 is 315. If you are very disinterested in tricks, you could just continue adding 45 degrees though. 135 plus 45 is 180. 180 plus 45 is 225. 225 plus 45 is 270. 270 plus 45 is 315. And 315 plus 45 is 360. I just think that adding that amount, 45 degrees, is kind of hard. Now we're going to add the next layer to our unit circle. So it's sort of like we're cooking, you know, you have to put things in a certain order to make it easiest or best. So we're going to count by 30 degrees now, which was 1/6 of 180. Counting by 30s is much easier than counting by 45 if you ask me. I'm not going to write all of the 30-degree increments on this circle. That's going to be for you to add. I will do them out loud though, because I do want you to have a bit more independent thinking, okay? So let's see, up here at 90, we're going to add 30, that's 120, 150, 180, checkpoint, we're good. And even if you have to work backwards from 180 to 150, that's actually easy sometimes. And then 150 minus 30 is 120. Instead of going from 2-digit adding to 3 digits, some people mess up. 180 plus 30 was 210, plus 30 was 240, 270, 300, 330, 360. So we add 30 all the way around. So I didn't write it, but I want you to copy that down. Make sure you have it in your notes yet again, because this cannot be practiced enough, okay? Now, this time around, we're going to do another circle, and I'm just layering them separately. I'm doing the radians over here. 1 full measure in radians is 2 pi, just like we saw in our circumference formula for many, many years. Halfway between 0 and 2 pi is 1 pi. Halfway to 1 pi is half pi, or pi over 2. And then halfway to pi over 2 is pi over 4. Now from here, all we need to do is count by the pi over 4, which is much easier than counting by 45 degrees. 2 pi over 4 is next, which is actually pi over 2. 3 pi over 4 comes after that. 4 pi over 4 reduces to pi. 5 pi over 4 comes after that. 6 pi over 4 will be my next angle, but I'm going to write that reduced, and that would be 3 pi over 2. So 3 pi over 2 and 270 degrees are equal. Wouldn't be a bad idea to remember that. After 6 pi over 2, after 6 pi over 4 is 7 pi over 4, and then 8 pi over 4 is the same as 2 pi. So we know we did it right. Okay, now we are going to count by 30 degrees. However, in the language of radians, 1/6 of 180, 30 degrees, is really the same as 1/6 of pi. So that means you start with a pi over 6. Count by that much. 2 pi over 6 is pi over 3. 3 pi over 6 is pi over 2. 4 pi over 6 reduces to 2 pi over 3. 5 pi over 6 is next, which is just 1 pi over 6 away from 6 pi over 6, which is pi. 5 pi over 6, 6 pi over 6. Next is 7 pi over 6. 8 pi over 6 is next. That reduces. Make sure you don't hit that 5 pi over 4 spot, okay? Make sure you skip that. It's only these that I'm making in orange. 8 pi over 6, which reduces to 4 pi over 3. After 8 pi over 6 is 9 pi over 6, same as 3 pi over 2. 5 pi over 3 is our 10 pi over 6, and then we finish strong. 11 pi over 6, 12 pi over 6 is actually 2 pi. Now I'm going to recommend that you redraw this yet again. I cannot stress how important this is to you enough, okay? Draw it again with a circle this time. Try to do it without looking at anything. Put your degree measures inside of the circle and your radians outside of the circle, like I do here, but turn your screen away from you and try it by yourself. When you're ready, come back. Now, if you're back at this point, what I need you to understand about this little circle is that this circle is actually the same as a circle on this graph paper that you could see here, with 1 unit as the radius, okay? It's called the unit circle. The radius is 1 unit. There is a reason as to why that is. We will talk about that more in our next lesson. However, if I asked you to draw this to scale on graph paper, that would be crazy. We blow it up nice and big so that we can really get in there and label all of these really important things that we need, okay? I'd always recommend using plain paper or graph paper for this. I feel like lined paper is a little confusing, okay? Another thing is, since it's on the XY axes, we can understand that this middle spot right here is actually the origin. That's 0, 0. It does have an ordered pair, and we can actually figure out the ordered pairs of our quadrantal angles. The quadrantals are the multiples of 90, separating the quadrants. So what would those ordered pairs each be? Remember which is x and which is y, left, right, up, down. You should know that this spot is 1, 0. Up top over here at 90 degrees or at pi over 2, your ordered pair will be 0, 1. You need these ordered pairs going around right now. Next, we want to put this ordered pair here at pi. That's going to be -1, 0. Don't mix up the x and y. It's very important that you are putting them in the right order, okay? So take your time. Here is 0, -1 down on the bottom at 270, okay? Now we really need all the ordered pairs, and we're going to focus on quadrant 1 only right now. 30 degrees, I don't have a number there yet, but I do know my radius is 1, and if I sweep my radius, I will have this distance of 1 to the origin from where I have my tick marks crossing my circle, okay? So for this 30-degree angle, or this pi over 6 angle, the radius of 1 for the circle is like the hypotenuse of 1 in the triangle that we solved when we warmed up. As you should have in your notes from just a few minutes ago, the side lengths are 1/2 and radical 3 over 2. How is that helpful? Well, that means I move over root 3 over 2 and up 1/2. I also mentioned before that root 3 over 2 is bigger than 1/2, so it's sort of helpful when you think of the scale that you're moving over a little bit more than you're moving up. Now, we're going to look at this 45-degree angle. I could make a 45, 45, 90 triangle right where I'm tracing that matches the 45, 45, 90 triangle we did in our warm-up. When the hypotenuse was 1, we found that our two legs were radical 2 over 2. I shouldn't need to do this over. It was something we did together in the warm-up. And if you're still confused, go back and watch that again, okay? So that means you're moving to the right from the origin, root 2 over 2, and then you move up root 2 over 2, and you'll hit the spot where that tick mark crosses the circle yet again. Now, the last ordered pair at pi over 3 or at 60 degrees is actually super, super easy because it's actually the same triangle. It's a 30, 60, 90 triangle. It's just sort of flipped over and sitting in a different direction. So we're going to move over 1/2 and we're going to move up root 3 over 2. Now, there's a lot of symmetry happening in this circle, okay? I want you to tell me the ordered pairs of these remaining tick marks. There is no crazy calculation left for you to do, okay? You are just going to do a lot of reflecting. If you take this triangle right here and flip it horizontally over the y-axis, the lengths of the sides of the triangle stay the same, even if I reflect it vertically, if I reflect it horizontally. The lengths of the sides of the triangle stay the same. The way you show the ordered pairs are different is that you'll incorporate negative signs. If you move to the left and then up, like in quadrant 2, you're going to have a negative comma positive. If you're in quadrant 3, you should have 2 negative values. And if you're in quadrant 4, you should go positive to the right and then negative down, but do not guess, okay? You don't want to guess while you're doing this because a lot of people assume certain patterns. I'm going to just highlight these ordered pairs so you could see them a little bit better. When you do your homework, you'll see I ask for you to do certain things color coordinated, obviously to the best of your ability. I know you might not have like a pack of highlighters or colored pencils or something handy. I think I assign certain colors to certain things. I think degrees are green, radians are pink, ordered pairs are yellow. So check out the homework assignment and good luck.